Welcome to the Personal Tutor Virtual Classroom. Friends, I am glad you chose to study with Personal Tutor, and I am extremely happy to be part of your academic journey as far as physics for high school is concerned. We are still on the series Kinematics. In our previous lesson, that was lesson number 2, we did look at motion of a body, and particularly we looked at some basic terms of motion. Those terms were called the parameters of motion, and I entreated all learners to understand them, keep them, and know them very well. Today, this is lesson number 3, and the lesson's topic is equations for uniformly accelerated motion. The learning outcome would be, at the end of this lesson, student would be able to write with minimal error the Newton's equations of motion. Again, we'll look at derivation of the Newton's equations of motion, and students and learners should be able to do so as well after the lesson. Then lastly, using the Newton's equations of motion, we will solve some relevant problems. So this will be the learning outcome for today's lesson. Let's start with the first one, and that is Newton's equations of motion. The Newton's equations of motion was gifted to the world by Sir Isaac Newton. And this equation for the uniformly accelerated motion are as follows. The first one goes like V equals U plus 80. The second, S equals UT plus half AT square. Then the third, V square equals U square plus 2AS. So my happy scholars, these are what we refer to as Newton's equations of motion. The U simply means initial velocity, and it is in the unit of meter per second. The V is the final velocity. It is also in the unit of meter per second. The A is the acceleration, and it is in the unit of meter per second square. The S stands for distance or displacement, and it is in the unit of meters. Lastly, the T is time, and it is in the unit of seconds. Friends and happy scholars, at this moment, I entreat all students to take particular interest and look at this equation, as they will form the basis for many tasks yet to be done. Under motion under gravity, motion on inclined plane, then projectile motion, these equations will still be used in a modified form. So kindly take interest in looking at this equation. Now, the next subtopic is derivation of the Newton's equations of motion. How did Newton come about all these equations? So within the next few minutes, we are going to think like Newton to derive these equations. Let me switch to the writing board so I can write from there. Now, guided by this preamble, let's derive the Newton's equations of motion. Consider a body with an initial velocity u and moving with a uniform acceleration a for a time t. to attain a final velocity v after traveling a distance s. From the first equation, v equals u plus at. How did this equation come to be? Happy scholars, this equation was extracted from the definition of acceleration. During the second lesson, we learned that acceleration is the change in velocity over time, the rate of change of velocity of a body in motion over time. And we ended up with this formula: A for acceleration equals v minus u. That is final velocity minus initial velocity all over time. So that is the equation of acceleration. From here, v was made the subject. So simply we need to cross multiply. And that will be v minus u equals a by t. v was made the subject, as I said. So make v the subject of the relation, meaning you will have to cross the other side, and that will be v equals at plus u, plus because it was originally negative. From here, the equation was rearranged. So v equals, then the u was stated first before the 80 plus 80, and that is how the first equation v equal u plus at came into being. I usually refer to this first equation as the father equation. It is a little drama I add during my lessons so that students can capture very well. With the father equation, it means we need a mother equation and offspring equation. However, the other two equations are the offsprings. The mother was not part. So we need now find the mother equation. Then we'll go ahead and find the other offspring equation. The mother equation was actually found from the definition of average velocity. During lesson number 2, average velocity was defined as the ratio of the total distance, the total time taken. Okay, so mathematically, let's have this to be the average velocity, and it's equal to total distance, s, divided by the total time taken, t. From here, if s is made the subject by cross multiply, s will be equal to the average velocity times time. Okay, so let's refer to this as equation A. But mathematically, the word average also could stand for mean. And mean simply means the summation of terms over the quantity of the term. So if I have 2 terms and I'm supposed to find the average, I add them up divided by the 2. That's the quantity of terms. If you have 3 quantities, you sum them up divided by the 3 quantities. So we can also say mathematically, average velocity, meaning you have to sum up the 2 velocities. That is initial velocity and final velocity. So I can write v plus u divided by the number of quantities, which is 2. Let's call this equation B. Now all we do is that you put or substitute equation B into equation A, meaning the place of average velocity in A will be replaced with v plus u over 2. So this will generate an equation like S from equation A equals average velocity now v plus u over 2 then times t. Okay, friends. Now with this matter equation, let's proceed to find the other offspring equations. So the equations are getting interesting and a little fascinating. Having had the father equation and the mother, let's now prove how the first offspring equation S equals ut plus half at squared also was proven by Newton. And that was achieved when V equals u plus at being the father equation was substituted into the mother equation S equals V plus u over 2 times t. Meaning, the place of V in the mother equation will be replaced with u plus at. So that will yield S equals, instead of V, we code the whole of this, u plus 80, then plus u, all of this over 2 times the t. Can you look at it? All we have done was to replace v in equation, the mother equation, with the value in the father equation. So expanding this, we'll have S equals, there are two terms here which are like them. That is u plus 80 all over 2 times t. S will be equal to, the summation of this is 2u plus 80 all over 2 times t. Expanding the bracket, you have S equals, this t is over 1, don't forget, and so t times 2u will be 2ut plus t times at will be at squared. So all over 2. Okay. Now, mathematically, this denominator is for both 2ut and at squared. And we can split it for both of them by maintaining the value 2. And so it could be written as 2ut over 2 plus at squared over 2. And I trust you are not confused here. So originally, this is how it was. And when you find the LCM, it will be 2. Okay. And S is equal to, you bear with me that these 2 here will cancel that 2. And you'll be left with ut plus at squared over 2. Then it can be written in this way as S equals ut plus the division of 2 can also be written in fraction form as half. It continues as at squared. And interestingly, that is how the first offspring equation was also proven. So far, we have proven the first equation, v equals u plus at, and the second equation, s equals ut plus half at squared. We are left with the last equation, which is v squared equals u squared plus 2as. To prove this, from the further equation, make t the subject. And so, this is the further equation. To make t the subject, you will have to join the v, and that will be v minus u equals 80. To find t, you divide both sides by a. And when a cancels out, you will have t now to be equal to v minus u over a. So with this called equation C, substitute that equation C into the mother equation S equals v plus u over 2 times t. Okay, so that will be S equals v plus u over 2 times t. And t is now the equation C, which was formed from the further equation. And that will be v minus u all over a. This calls for expansion. So we need to be very fast on it. You pick the first parameter here, or variable v, then you multiply by everything in the second bracket. I believe you know your algebraic expression. So that will be v times v amounting to v squared. Then v times negative u will be minus uv. So that is the first expansion. You then pick the positive u and multiply by everything in the second bracket, the numerator first. So u times v will be plus uv. Then u times negative u will be minus u squared. All of this over, then now you multiply the denominator, and that will be 2a. From the numerator again, negative uv and positive uv crosses out. They are like term, one is negative, one is positive, so that turns to 0. And you are left with v squared minus u squared all over 2a. From this, you make v squared the subject of the relation. So that will be done by cross multiply. And you will get v squared minus u squared equals s times 2a will be 2as. From here, we are making v the subject, and so u will have to travel to the other side. And we'll get v squared equals 2as plus u squared. All you do next is you rearrange to suit how Newton solved his. And that will yield v squared equals, the u squared will then start as u squared plus 2as. So simply, the next offspring equation is v squared equals u squared plus 2as. And that is exactly what Newton gave us as an equation. And that is the last equation, referred to as the offspring equation. So, friends and happy learners, through this drama, we have been able to derive the Newton's equations of motion. The first one, v equals u plus 80. Then the second one, s equals ut plus half at squared. Then the third, v squared equals u squared plus 2as, where all these terms has been defined for you initially. So don't forget that these are the offsprings, and that is the father equation. It is the mother equation which did not form part of it. And when erased, we are left with these three equations. Take note of it, stick to it, and learn it very well. Thank you very much. So, before we solve problems using the Newton's equations of motion, I will want you to take notice of some of these phrases. You will be given some statement or phrase within the examples. These are the meaning. First, if you have a statement like a body is at rest, a body accelerates uniformly from rest, a body starts from rest, a body initially at rest. The common thing among these is beginning from rest. All it means is then the initial velocity is 0 meter per second. That is the meaning of this statement. Again, if you are told in the question that a body is brought to rest, a body retards or decelerates to a full stop, a body moved to a uniform rest, the brakes were applied to bring a body to a full stop or rest. This statement also means that the body was in motion and it was brought to rest. It was decelerated or retarded to rest or came to stop. It simply means the final velocity is 0. So V will be 0 in this instance. And another meaning to this is then the value of the acceleration is negative. In this sense, it is a deceleration or a retardation. So take note of these phrases and statements. They will do us great good while we are solving this question. So let's start with example number 1, which reads, a body accelerates uniformly from rest at 7 meters per second square. What would be the body's velocity after 5 seconds? In order to solve this question, you have to list from the question the data given, the parameters that were mentioned in the question. So a body accelerates uniformly from rest. From the just ended statement, because the body is starting from rest, its initial velocity, u, is 0 meter per second. Then it was accelerating at 7 meter per second square. So this per second square tells you it is an acceleration, 7 meters per second square. What will be the body's velocity after 5 seconds? 5 seconds is time. So t is equal to 5 seconds. We are looking for the body's velocity. And obviously, it is the final velocity v that we are looking for. And the clue is already there was an initial velocity of 0. And so if there is any velocity to be calculated, then it's the final velocity we're talking about here. Now, which equation suits what we are looking for? We are finding v. If you look at equation 1, there is a v. Equation 3, there is a v. Now, starting from the equation 3, I will need u, a, and s in order to find the v. Okay, so u is given. A is also given, but s is unknown. In view of that, the equation 3 cannot be used to find the v in this situation. Checking the equation 1 that has a v, you need u, a, and t before you can find the v. Let's check. U, yes, is given. A, yes, is given. T, yes, is given. And so the equation that can work in this situation is we have to use V equals U plus AT. So you see how I was able to get the appropriate equation? That is how you also ought to do by simply looking at the parameters given and what you are looking for. So let's make a substitution. V is unknown, but U is 0 plus A is 7 times T, which is 5. In this case, V is equal to 0 plus 7 times 5 is 35. So V is equal to 0 plus 35 is still 35. And the answer will be in meter per second. So that is the body's velocity. That's the V that we are looking for. Thank you very much. Let's take a last example. Example number 2. An object starts from rest and moves with a constant acceleration of 0.5 meters per second square. Calculate the distance covered by the object in 10 seconds. Let's list the parameters and data given in the question. So from the first statement, an object starts from rest, which has the interpretation as then the initial velocity U is 0 meter per second and moves with a constant acceleration. So there is A acceleration as 0.5 meter per second square. Calculate the distance covered by the object in 10 seconds. Time is also stated as 10 seconds. We are supposed to calculate for the distance, and that has the symbol S. So it is the distance that is unknown. With my equation, I'm looking for S. So automatically, equation 1 does not qualify. But in equation 2, there is S. Equation 3, there is S. Which of these S are we finding? Or which of these equations can help us get what we are looking for? If we use equation 3, V, you need V, which is not given. U is given, A is given to find S. So long as V is not given, equation 3 does not qualify. Now equation 2, S is what we are looking for. We need U, T, and A. Is U given? Yes, 0. T, 10. A, 0.5. And so the equation that qualifies to solve this problem is S equals UT plus half AT squared. Let's substitute. So S equals UT. U is 0, whereas T is 10, plus half of A. And the A is 0.5. Then T squared, that is 10 exponent 2. Already, this will amount to 0 plus half of 0.5. Then 10 squared is 100. S equals 0 plus half of 100 is 50. And 50 times 0.5 will be 25. You can use the calculator to assist us in that regard. And as I said, on the calculator, that will be 25. So 25 here. So finally, S is equal to 0 plus 25, amounting to 25, and it is in meters. That is distance. So thank you very much for your audience. It's been a long journey, but it's worth it that you have stayed with Personal Tutor. See you and stay blessed.